Are we ready to go here? It's my pleasure to introduce Dr. Derek Riley, the director of MSU's Computer Science program, which I contend is really an AI program in disguise. I think one of the things I really enjoy about this conference is how we're looking at advanced topics like AI, but also looking at how we can bring them back even out into our companies, into our schools. And I think you're going to enjoy Derek's down-to-earth and engaging approach to this topic. A full professor, Derek's teaching and research areas include software engineering, machine learning, modeling, and high-performance computing. Speaking of modeling, Derek earned his PhD at Vanderbilt University in 2009, where he modeled biochemical and industrial systems. Derek also provides consulting services, you might want to talk to him afterwards, and is a member of the ACM. So without further ado, Derek Riley.
Thank you, Dr. Yoder, and thank you to organizers for having me. This is a really fun conference. So the talk today is all about vibe coding. So many of you, maybe most of you have tried it. Some of the content I have on here may be an eye chart. I might click through things quickly. So I have a QR code here. You can go there to a GitHub that has the slides, has some example code. I'll have that QR code at the end as well. So feel free to go there, or if you don't get it quick enough, I'll put it up at the very end again. So vibe coding, we all have heard a lot about that recently. I teach software engineering classes, AI classes, so I'm teaching a software engineering class this fall, and I thought, okay, well, I want to see what project I'm going to give my students and how it goes. So I was thinking about updating the project, and so the software engineering class is for sophomores. It's for students who want to, or we're teaching them how to work in teams with Scrum and collaborate. And we want this to be modern, so they're using modern tools. So I want to make this AI forward. And I thought, okay, I'll have them build an elevator simulation project. So I came up with a description of the project, like I've done in previous years, to hand to students. And then I thought, well, what happens if I gave this to Claude Code? So I gave this prompt to Claude Code. And this is the result. It gave me a fully functioning elevator simulation in less than 5 minutes. So you can go ahead, I didn't tell it anything about how to make the GUI. I didn't tell it really much beyond make an elevator simulator that says you can import and export different files. You can select buttons for, these are like the lights inside and outside the elevator. I didn't tell it what an elevator was. It knew all of this, right? It's got banks of elevators, all this sort of stuff. And it does have bugs. There are some issues that would need to be fixed if you're going to use this to actually build a real elevator simulation. But in the span of a couple of minutes, I was able to build this. And this would have been a project that I would have expected a team of 3 or 4 students over an entire semester to have to take the time to build. That is what has changed in the last couple of years. Claude generated about 4,500 lines of code for me this is basically just like fully vibe coded, didn't really think about it. I used Claude Sonnet 4. And then because I was too lazy to really scrutinize, 4,500 lines is a lot of lines, right? So, and I was just working on this last week. So I asked another AI tool to evaluate the code for me. And I said, hey, tell me about how good is this code? So it gave me an evaluation of maintainability, professionalism, so on and so forth, right? This is great and scary simultaneously, right? Most of us have probably experienced something like this, but as a professor, you go, okay, this is going to change the way that we teach and change the way that we approach software development. I just like to go back to the quote from Marvin Minsky. So this is actually Marvin Minsky in 1966, sitting in front of a then modern computer. He said, artificial intelligence is when machines are doing things that humans are assumed to be intelligent to do. This is what we have reached the age when software development is now one of those things. I want to take a step back and talk about language. Who in the audience considers themselves to be fluent in one language other than English? Raise your hands. Okay, all right, yeah, so maybe a third or so of the audience, that's great. How long did it take you to learn that? So maybe 5 or more years? Anybody out there took a long time? Yes, there's some language that takes a long time, or our journey takes a long time. 3 to 5 years? 1 to 3 years? Anybody's really quick at picking stuff? Anybody pick up something in a matter of months? Okay, so it turns out that different languages actually take different amounts of time to learn. The US State Department puts out this map that shows from English to another language which are increasingly more difficult to learn. And it turns out learning language is a hard thing for humans. Some people are better at it than others. I am not all that great at it, but why do we learn another language? What's the point? We can get all these cultural things and that kind of stuff, but what really is the point of learning another language? Communication, exactly, right? And why do we want to communicate in a different form than what we natively communicate in? Aha, because other people have information that's useful to us, or we want to collaborate with them, right? So I'm going to make the argument that actually we translate between human languages because of first contact. I asked AI to generate what first contact looked like, and this was a sort of creepy picture it came up with. So I have a lot of AI-generated images in this, so just I'll apologize once and leave it there. Before first contact, we didn't need to translate, right? Everybody in our tribe spoke the same way, said the same things. We didn't have to worry about translation. So once we started interacting with people of different cultures, we had different ways of describing the same thing. We needed a way to map those things together, right? And that's really what precipitated the need for us to be able to translate. So this is a great opportunity to talk about the difference between syntax and semantics. I gotta squeeze in a little of the theory stuff here, right? So what is syntax? Syntax is the structure. It's the form of how we speak and write, or how computers speak or write. And these do evolve differently in different societies. And so we have a shared understanding of what the syntax is of our language. And actually the syntax we use for our language today is different than what it was 100 or 200 years ago. The semantics is a more abstract thing. It's the underlying meaning of what we are speaking or writing about. So I like to, say, okay, if I held an apple here in my hand, then you would all have this conceptual idea of what an apple is. In fact, you might even smell it or taste it. Like you have this really rich understanding of what something is. That's a semantic understanding, right? But we have different words for it. So the syntax of the words, semantics, the understanding, right? And since the beginning of time, since first contact, maybe I'll put it that way, we've had to figure out how to translate between the semantic and syntactic mappings. So we start out with human translators, right? There's some people really good at figuring out languages and figuring out those mappings between languages. But humans are sort of inefficient. And we still have the need for human translators, but that's still sort of inefficient. Anybody who traveled internationally prior to 2000 probably bought a vocabulary dictionary. I don't think any of my students probably do this ever, but I remember, first time going to Europe, you get this big thick dictionary that's where's the bathroom? How do I say bathroom? And you flip through the dictionary to find that syntactical translation, right? But that's sort of inefficient and slow too, right? So we moved to the internet. Right now you can ask Google to translate for you. That's really handy. And of course it's driven by an AI system. All of these systems, and now there are AI systems that do real-time translation, right? Speak into your phone, get the other language out in real time. Each of these tools are solving this translation problem better, faster, cheaper, right? That's basically technology. So LLMs, right? This is the elephant in the room. Let's talk about it. LLMs, I assume everybody knows about them, but it's worth talking about some of this background because that's really the engine behind all of the vibe coding and things that are happening that are evolving software development today. Large language models are just that. They're designed to work with natural language. And they use parameterized knowledge. The prompts are embedded so that we have this translation between the formats. And they actually have a fairly mature history at this point. There's a gazillion different models out there. There's a new one every 24 hours, it seems. They run on every platform. They run on all sorts of different hardware. Really, these are kind of becoming commoditized at this point, right? So what we're doing is we're seeing more and more layers built on top of these LLMs that really are what are enabling this translation shift that we're seeing. So the mindset when it comes to software development is shifting. And it's shifting because these LLMs do way more than just translate language. In fact, that was their first, one of the early value adds in them is they could translate between syntactic and semantic understandings really well. But now if we apply these to software development, it turns out they can, of course, understand the syntax and semantics of a software language or multiple languages to translate between languages. But they can also do things like debug your software and re-architect your software and evaluate your software and plan and evolve and execute new steps in developing software. So it goes way beyond just translation. Translation is sort of the first step, but now they can do a whole lot more than that. And still, under the hood, it's just an LLM. These AI tools are really going to cause us to develop software differently. It enables us to be high-powered software developers. Partly because it doesn't get fatigued like we do. Of course, it generates utilizes a lot of electricity and that sort of thing, but it doesn't ever say, no, I need a break. I've never gotten that response from an LLM. So that's actually kind of a big advantage over even myself, right? So to be able to unlock the abilities that we have with these LLMs, we have to be able to delegate to it. And this is the big change that I've seen that is already here in software development, is instead of being a programmer or structuring your code and designing the code yourself, we're going to be teaching students how to delegate to agents to do that. You're moving from being an engineer to being a manager of engineers. That's a very different skill set, and I think we have to train students differently, and those of us who are already in industry have to think differently when we develop software, because the way you manage people or entities, agents, is different than if you're going to develop it yourself. And it's worth saying that writing software is a much harder and more complex problem than just doing a simple translation, right? We're not just trying to say, what did this person say, and give us a simple translation. It's way more complex and nuanced. The syntax matters less and less, and the semantics matter more and more. So we're going to be delegating to these AI agents through prompts. That's the way software development is going to exist in the future, or actually already exists today. Whether we accept that or not, this is the way that I see that things are going. So to be able to do this, we have to be able to speak to AI agents. And the way we speak to AI agents is through prompts. So we have to be fluent in a prompting language to be able to interact with agents effectively. So it turns out that when we prompt these systems, the complexity and nuance increases as the interaction length increases. And context really matters. So if I say fruit flies like a banana, what does that mean to you? It actually has two meanings. They're both shown up in pictures up there. You could interpret it two ways. You probably could interpret it more than just two ways. But you could be talking about fruit flies, like the insect, or you could be talking about like the verb, like the fruit flies, right? How do you know which is correct? If I throw it at you, it's flying, right? Context, right? Somebody said context. So I feel like, people always picks the person of the year. I think if they're, whoever's picking the word of the year, context, I feel like should be the word of the year, because it's all about the context. Where you see that text, the environment, everything else around it is really what's important. The LLMs, to be able to do useful work, have to have the context, right? They have to have the fruit flying at them to be able to know, or to see the flies buzzing around. So when we're interacting with an LLM, are bringing assumed knowledge. We assume that the LLM knows things, right? But you just fire up a ChatGPT browser. What does ChatGPT know about you? Well, you may have given it some things. If you have the pro version, you give it some things. You upload a document. It has those things. But wouldn't it be nice if we could do a little bit more than just sort of hope it does? Okay, so I might call out your software engineering credentials out here, but who knows or remembers or heard of SOLID before in the context of software engineering? All right, so we have some real software engineers out there. That's good. So SOLID is a set of design principles. It's an acronym. It stands for single responsibility principle, open closed design, list-off substitution, other stuff, software engineering stuff, right? So these are good practices for developing software systems. They're kind of ways that we evaluate the quality of a design of a piece of software. Does an LLM know what solid is? How do we know? Well, we could ask it, right? We could just say, well, what if I have a code base? In fact, that code base I first generated, and I asked it, evaluate my code base according to solid principles. That's all I gave it, and this is what it gave me. It actually generated this whole list where it says, okay, well, according to the single responsibility principle, we have mixed compliance. And it goes through a list of things that the code it generated, although it was a different language, different LLM. But the code that it read, it evaluated, right? And then it goes through, and I just cut this off because, of course, like in any LLM, it vomits tons of stuff that you have to go through, right? So it turns out that this LLM, so this one was Claude Sonnet 4, knows what solid is and actually does a pretty good job of evaluating your code base according to these criteria. So we don't need to provide it the context of what solid is. It does a decent job of that. In fact, it even does a summary and gives us an assessment of strengths, areas for improvement, and other things like that, right? Wow, this is pretty handy, right? This might be actually useful. So I want to talk about this context thing because understanding what it has for context and what you need to add to context for it is critical. It's just like if you're talking to somebody who speaks another language, often there's lots of gestures to things if you don't really speak the language super well. We have to know what gestures to use when we're talking with the LLM, right? So you might just see that chat window down there, but under the hood, there's a bunch of other stuff. There's core instructions that are given to the LLM that are appended to every single LLM call. There's some content knowledge. There might be some few shots, a few examples of things. You might have like chat history in there, and a bunch of other things that can exist in this context window. If you're not explicitly setting the context, it's being done for you. And so the more control you want to have over the output of your agent, the more intention you have to put behind what goes into that context window. So, surprise, surprise, software developers say, how do we have more control over this? Well, let's just build our own system. But instead of building our own system, let's just fork Visual Studio Code. Because that's easier, right? So a couple MIT students in 2022 were like, hey, let's build our own thing. It's called Cursor. It's valued at a paltry $9 billion at this point. How many people out there have used Cursor? Just so I get a vibe of, okay, yeah, about half the crowd. That's great. So Cursor's fantastic. It's really great for vibe coding. And basically, it's an IDE that lets you, that helps build your context in a meaningful way. So there's a lot of stuff going on. If you haven't used an IDE before, I'm going to sort of presume you know at least a little bit about writing software. But you have a software system, there are lots of files. You might have scripts about building things. You have other instructions. You have documentation. All that stuff can exist in the IDE. And if you have a substantial project, you're going to have way more than what can fit in that context window. So what this tool is going to be doing is deciding what's the right stuff to put in the context window to help answer the questions that you have. It's not just a chat window on the front of this. It's doing a lot more sophisticated things. So this is actually an outdated diagram, but I like it because this was sort of state of the art as of 2 years ago. This is what GitHub Copilot did in their sort of code completion system. So it's just finishing, not chatting. How does it do those code completions? Basically, it's taking any open tabs that you have. It's taking data from the editor. It's taking stuff that might be in a vector database that's been saved. It also may have a prompt library. It's generating the prompts, and then generating a couple different potential code completions, showing them to you. It's generating them, sending them through the GPT model, and then showing them to you so you can pick which ones you want. So some of that stuff is happening locally, some of it's on the server. There's a ton of complexity going on behind the scenes to assemble this whole nice, neatly packaged context window that you as a developer actually never see. This is all sort of being done for you so that you can just hit tab. This is this is really the shift that we've seen is 2 years ago, what we were really focused on is making these LLMs more useful by stuffing more and more relevant context in our context window. we've now moved to the point where we go, okay, so those things can translate and they can give us good suggestions, all that kind of thing. But a lot of our effort as a software developer is more than just like, how do I finish this line of code? It's how do I actually like make sure that this thing passes tests, and what tests should I write, and is this in the right framework, and that kind of thing. And so we've shifted then to this sort of agentic way of thinking. The idea of agentic really is putting tooling into this kind of LLM environment. So instead of just building a nice context window, it's going to actually maybe call a database call to get what is the structure of a table, or it's going to actually like load a file, or it might do a command to get the directory structure so it can understand your project a little bit better. So it's basically adding a bunch more steps to do a better job of gathering the context before it runs the LLM prompt to give you an answer. So I think this tooling thing is actually kind of a big deal. We make a distinction in the biological world between animals that can use tools and animals that can't, right? And we generally say, okay, if an animal can use a tool, it's smart, and if it can't, it isn't. So I think once we move from this world of agents and LLMs not using tools to LLMs actually using tools effectively, I think we're actually working with smart systems here. I think, by our biological criteria, these things are actually getting to be intelligent, I think arguably. What kind of tools are we talking about? So they can do searching. So it's like, hey, I'm making a reference to something. The LLM doesn't have the context figured out. It can go through your code base or the internet to find it. Obviously, editing, compiling, that's sort of handy. Running things. MCP, this has been mentioned in a couple of the other talks, but Model Context Protocol, this is if you have your own thing, you want to have a tool that's built up in your own ecosystem, you want to call that, you can then basically set it up so it can do that as well. And it turns out now, this has been so useful that now LLMs are trained to be effective at actually designing in triaging, understanding what tools they should be calling in what order to be able to make this work. There's a clever guy who reverse engineered Cursor's system prompt. I realize it's an eye chart. That's why I gave you the slides earlier. So you can look at this later if you want, and I have the source link in here as well. But if you go through this system prompt, you're going to notice some structural things that I actually think this is mostly focused on software development, but the reality is these are good practices for prompting in general. So So at the beginning of almost every prompt, we're going to have some sort of persona. When we're talking about software development, often the persona is telling the AI agent what it is. So you're a software engineer, you're a software developer, and telling it the context of where it's operating. So telling it that it operates in Cursor gives it some context as to, oh, it's in an IDE. You don't have to tell it that Cursor's an IDE, it actually knows that. We have to establish the persona that sort of guides where the thing is going. It identifies the agentic tools that exist, and there's a bunch of structure about how to do that. We're using structures like XML sorts of things. There's always context in there and other things like that. So really, there are best practices for how to set these prompts up to be able to get them to work. And this is what's happening behind the scenes to make all this magic sort of happen. So I should probably define vibe coding because this talk is supposed to be about vibe coding. So vibe coding, I really think of as a software development style where the developer really heavily uses the LLM to write and debug the code. The idea is it's mostly focused about generating code and less about scrutinizing that code. So speed over quality, not scrutinizing stuff a lot. And this is a relatively modern term. It's kind of hard to believe we've only had this term for like 6 or 7 months, but because it feels like it's in like the lexicon now. But at any rate, yeah, this is the pace of change that things move at. So really, vibe coding is a little bit scary because these tools are so capable, you build trust with them, and then you just go, hey, yeah, accept, like I'm good with this is fine, and then bugs get pushed. So I thought to that end, we should go back to a good old game show from middle of the day television and say, let's play a group game of Family Feud and see what vibe coding challenges have you heard about, and we'll see if this works. But yeah, so what challenges exist with vibe coding? Anybody?
Physics fall inside the circle.
Say more about that. I was thinking about like broader things, but yeah, say more about that.
It's just a simulation of physics to a degree.
Okay. So what I was looking for are what are some broad problems that exist with vibe coded software? Yeah. Yeah.
You have a bias for complexity.
Aha, complexity limitations. Good answer. What's next?
I don't know the term for this, but like infinite edits. It's like something doesn't work, and you're like, hey, fix that. It's like, okay, I fixed it. Your fix doesn't work. Hey, fix that.
Yeah.
Like that.
I know exactly what you're talking about. That's a real thing. I didn't get it on my list, but it's a good suggestion. I like it. Thank you. Yeah.
Compounding error problems, where it successfully tries to solve something and you don't catch it in time, and then it keeps going thinking that it's correct.
I'm going to put that under code quality issues. That is absolutely, yes, that is a real problem. I agree. Yeah.
Code bloat for no reason.
Yes. And I'll put that under maintainability because that is, yeah, code bloat is definitely a problem. Yeah, Paul.
Unification.
Yeah, I'll put that under debuggability. I think that's true. Yeah. Over engineering. I don't have that one on here, but that's, yeah, I think, yes, definitely. I agree with that one too. I have two more.
Compliance issues.
Yes, thank you. Security issues. That's a big deal, right? And my last one, hallucinations. So, yeah, so there are lots of problems with vibe coding. We've all heard about them. I'm going to make the argument here and hopefully give you some examples of ways we can improve and avoid these issues. So why do they hallucinate? Almost always the answer is they don't have enough context. So I like to think about this like a student who studied, an LLM is like a student who studied really hard for a test, and then your prompt is like a closed book exam. That student has to solve that problem, but they don't have the context beyond what they studied, right? So wouldn't it be better if we gave them the textbook or a note sheet? They'll do better, right? So if we provide the right context, we can short circuit a lot of the hallucinations that happen. So think about what would you need to solve that problem? If your LLM doesn't have that, you can't solve it. What kind of things can you show in the context? So example, input and output, error messages. You can point it to files, things that have had the same pattern. Acceptance tests, requirements tests. Really, figuring out what level of granularity is fairly important, and this is something you can develop over time. I like to think about context like, imagine you're a composer, and you've been asked to compose something. The music you want to generate is your program, right? It's this new thing that you're going to be generating yourself. But you're under a tight deadline, so you can't write it yourself. So you have to delegate to others to write it. So if you're going to delegate to others how to write something that is your own composition, how do you do that and still maintain ownership of that thing? That's the challenge that we have, right? We're delegating some of the responsibility. And so it's a management problem, right? You don't want to get stressed out by the others. You have to trust those others that you're delegating to. You have to build trust with them. You have to figure out how much detail do you provide to them. Do you give generic instructions to all of them, or do you give specific instructions to some? I think they're really analogous challenges. Not all music is equally easy to generate in the same way that not all software is equally easy to generate. So how do we do this in Cursor? So in Cursor, you can provide the context. There's explicit ways that you can put it in there, or you can just trust it to search and find. There's also Cursor rules files where you can give custom instructions to guide the agent. There's a cursor ignore file where you can put stuff in there that says, don't look at this. This is a waste of your time, or it will fill up your window. Yeah. Another reason you could do this is you could give too much information. So if you give the LLM too much data, just like if you say, hey, you can have an open book exam, but here are the 10 books you have to look through, the student won't have enough time to finish that problem. So, yeah, if you give an archer a target to shoot at, but you don't really tell them which target to shoot at, it's in a foggy field, how are they supposed to hit that target? You have to give the right instructions. You have to make that target visible so that they're not just searching for a bunch of Waldos in a terrible Waldo, Where's Waldo image, right? So you want to give enough specificity and detail that allows the context to be focused in a way to lead it toward, look at this method, look at this signature, test with these unit tests, follow this pattern. And those little breadcrumbs are often enough and can do way more for your prompt than just saying, hey, this is a best practice. This is one of the, the best books to read on this architecture pattern. So specificity will guide the focus, and I think that's critical. I talked really briefly about this, but role. So defining the role matters. You can modify this, but you can have different roles like a full stack development expert or a security expert or a junior dev. There could be different approaches you can have, and those different approaches are going to actually give you different outputs in different situations. So you want to target the role to the right level of detail that you're looking for. You can do this in basically any of the IDEs in Claude or any of these. So in Cursor, you can set up rules that are sort of system level rules. You can also have rules that are specific to a project or a set of files. You can do a similar thing in Claude. Claude will also walk through a project for you and generate your own set of rules that you can then edit. Claude is a little bit more for folks who are not ready to give up the command line, but it also is really very capable. You're going to have to build trust with the LLM. This is just like if you're going to sit down in a self-driving car. If you put in a brand new self-driving car and you put in your destination and then took a nap, you're crazy, right? You wouldn't do that with an LLM in an IDE either. So you have to build trust. Trust comes from iteration. So you're going to have to iterate through different ways, and just asking the tool broadly to, hey, update my code base is just too broad of a target. You really have to help it focus on certain areas. So say, refine, my comments to a certain standard, or, can you refactor this to improve the performance of this XYZ system? You can ask the LLM for feedback, ask it for helping you figure out what to do. The focus shouldn't be on perfection, it should be on progress. And I think that's the right mindset, is you aren't going to just get in your self-driving car and expect it to have you at your destination. You have to build that trust, you have to build progress, and realize that there are going to be plenty of times it may not perform well. So what sorts of things can you do with agents? You can debug your code. This is an obvious use case, but I've got a bunch of prompts in here, by the way. I'm not going to go through each of them just for sake of time, but if you want to learn more about some example prompts, these are prompts I've used that were at least genericized that are somewhat useful. Feature blueprinting. So, hey, how can I build a certain thing using this tech stack? What can I do? Writing requirements. This, I think, is the thing my students are most excited about. Who likes, I won't make you admit it. Nobody likes writing requirements. Maybe a couple of you are going to disagree with me with that, but nobody likes writing requirements. LLMs don't complain. They don't get tired. They're happy to write requirements for you. Writing tests. Very similar, but yeah, generating tests is a really great way. Now, do they create tests that are sufficient for you to use on the next flight control system in an aircraft? I sure hope not, but they will generate some tests for you and at least get you through the writer's block stage of generating some testing framework at least. Refactoring is a great use case. Rubber ducking, so this is, I think, what this method does. What am I missing? So it lets you ask stupid questions that you wouldn't want to ask the person down the cubicle because you don't want to look stupid. But the LLM doesn't care, doesn't judge. It just, if you ask it to judge, it will judge. But it won't judge just outright, right? So evaluating things like code quality, I showed you that example earlier. It will also write prompts that will orchestrate all these things. I'm talking about these in isolation. There's no reason you can't do these all together all the time. That's what an agentic model is. It's taking and building a system of this. And this is really what I want to get to. This is the meat of the talk, I think, which of course I didn't leave enough time for. But you can actually use these tools with existing software engineering tools like Git. So just like if I was going to delegate a bunch of development to other developers, I would say, hey, develop this feature on this branch. We'll go through a merge process and all this kind of stuff, right? You can do that with your generative AI too. So you can instruct Claude to say, okay, before you make any changes, create and check out a feature branch, give it a naming template, and then make and commit your changes to that branch. This is truly delegation, and you can tell it also things like, oh yeah, and the nice thing about having it on a branch is you can then go inspect and merge and all that kind of stuff. All the same stuff you would have done. Oh, and Git isn't, I said Git, no. Claude isn't lazy about writing commit messages. I am, but Claude is not. And you can actually just augment your system prompt to tell it to do this. You can say, okay, don't just do this, but also write a bunch of automated tests first. Make sure the code passes the automated test before you commit. So you're doing all the steps you would expect a software engineer to do, and what you end up with a few minutes later is code that may or may not be tested fully, may or may not be running and working, but is much more likely to be running and working than if you did it on your own, and certainly done faster. So yeah, you can also use these tools to manage merging and merge conflicts if you're feeling really trustworthy. That will come. I honestly think like we're not that far away on at least sort of common code bases or sort of common languages. Like we're not that far away. That is in our future. Right now, the integration with these sort of at least CI tools are definitely there. Because time is short, I have a few lists of anti-patterns. I'm not going to spend the time going through those. You can look into the slides. I want to impart the importance here that this is a shift in our mindset. We're not just a software developer. You're an orchestrator. That is what the new generation of software developers is going to be. AI is labor, and I'm going to argue AI is cheap labor. At $20 a month versus, $80 an hour for a junior software developer, this is like not even comparable, right? So if you can leverage this labor, you're going to be a much more capable and effective software developer. But remember, what you're doing is probably not what you were trained for, right? Managing is different than doing. And so the architecture matters, testing matters, all these sorts of things change. It's also worth noting that micromanagement of AI systems is anti-pattern. Having too much specificity, having to go through and check absolutely everything, prompting to generate one function at a time, this is actually not allowing you to achieve the potential that you might be able to do. The more loops and iterations you have to do, the more time you're going to be spending prompting and engineering these things, and the less productivity you're going to ultimately have. It's going to limit your ability to be productive. So, yeah. So don't be afraid to actually inspire and challenge the agents to do things. If your agents aren't performing, don't look at the agent, look at your prompts, look at your context, look at your process. Those are actually the things that are going to need refinement as we move forward. All right, where's AI going? It's going to be everywhere. It's growing faster. This is not a surprise to anyone. Will jobs be eliminated? No, but if you're not using AI, you will be replaced by somebody who is. I'll say that there's this thing called Jervin's paradox, where it's an economics observation that some technological advancements, not all, but some technological advancements that create greater efficiencies actually increase the demand for the skill of those. So we suddenly say, well, we wouldn't have solved that problem because it's too far down in our backlog. Well, if our engineers become more efficient, suddenly those things that are further down in our backlog become more possible, and we might get bigger efficiencies. We might be able to take bigger risks, and that's potentially exciting. So I'll end with this. All models are wrong, some are useful. I think this one's useful. All right, I promised the Q. Yeah, we probably don't have much time for Q&A, but maybe a question or two. So, yeah.
We have time for one question.
You gave the elevator example at the beginning of a project you would give your students over the course of a semester. What would be an example of a project that you would give in your students in this day and age with these tools that is a semester-long project in the same kind of scope? Now that this is trivial, your original project is trivial.
I have about 2 weeks to figure that out.
Okay, awesome.
To be really honest, I don't know yet.
Okay.
Yeah, I have a couple ideas, but I'm not sure. Yeah. Good question. All right, well, I'll be around afterwards and at the dinner, so feel free to approach me with more questions. Thank you.